Have you ever wondered how a simple idea can revolutionize the world? Our story begins in the early 1980s, a time of big hair, bold colors, and the birth of a groundbreaking technology, 3D printing. This revolutionary concept transformed the way we create, turning digital blueprints into tangible objects layer by layer. The brainchild of this innovation? A forward-thinking engineer named Chuck Hull. In 1984, Hull introduced the world to a process he coined as stereolithography. This was the very first 3D printing process, a method that uses ultraviolet lasers to solidify layers of a liquid plastic called photopolymer. The laser traces a pattern on the surface of the liquid plastic, hardening it and forming a single layer of the 3D object. The platform then descends and the process repeats, layer after layer until the object is complete. But Hull didn't stop there. He recognized the potential of his invention and decided to bring it to the commercial world. In 1986, just 2 short years after developing stereolithography, Hull founded the 3D Systems Corporation. This marked a significant milestone, as 3D Systems became the first commercial company dedicated to 3D printing technology. Hull's vision was to make production faster and more efficient, and with his invention, he did just that. However, it wasn't just about speed and efficiency. Hull's invention also opened doors to customization and complexity. With 3D printing, we could now create intricate designs that were previously impossible or too costly to manufacture. It was a game changer, an invention that would redefine the boundaries of manufacturing. Thus, the journey of 3D printing began, paving the way for a new era of manufacturing. This was the dawn of 3D printing, a beacon of innovation that would light up the path for countless advancements in the years to come. The world of manufacturing would never be the same again, all thanks to a simple idea that revolutionized the world. As the 90s dawned, 3D printing began picking up pace. But what were the milestones? One of the most significant developments of this era was the introduction of fused deposition modeling, or FDM, by S. Scott Crump. This method of 3D printing works by extruding a thin filament of thermoplastic material layer by layer to build an object. Imagine it like a hot glue gun, controlled by a computer that lays down plastic layer upon layer until the object is complete. Crump's innovation made 3D printing more accessible and cost-effective, opening up an array of possibilities for industries ranging from automotive to healthcare. Around the same time, the 3D printing industry saw the formation of Stratasys Limited. This company, co-founded by Crump himself, quickly became a major player in the 3D printing landscape. Stratasys is known for its pioneering work in FDM technology, which played a crucial role in popularizing 3D printing. Today, it continues to be a driving force, constantly pushing the boundaries of what's possible with 3D printing. Meanwhile, another significant milestone in the 90s was the invention of selective laser sintering, or SLS, by Karl Deckard. This technique involves using a laser to sinter powdered material, binding it together to create a solid structure. SLS represented a game-changing approach to 3D printing, as it could create more complex and detailed objects compared to previous methods. It also expanded the range of materials that could be used in 3D printing, including metals, glass, and ceramics. These breakthroughs marked an era of rapid development and expansion for 3D printing. The groundwork laid by innovators like Crump and Deckard, along with companies like Stratasys, set the stage for the incredible advancements we see today. As we moved into the new millennium, 3D printing continued to evolve, becoming more sophisticated, more versatile, and more accessible. The 90s were indeed a time of rapid development and growth for 3D printing. The turn of the millennium was a game changer for 3D printing. But how exactly? Well, the early 2000s witnessed the expiration of key patents related to 3D printing technology. This seemingly mundane event was actually a significant catalyst for the democratization of 3D printing. With these patents expired, the technology was no longer the exclusive domain of big corporations. It was now accessible to smaller companies and even individuals, sparking a new era of innovation and creativity in the field. One of the most notable developments in this regard was the emergence of RepRap. Short for Replicating Rapid Prototyper, RepRap was an open-source project with a lofty goal to create a 3D printer that could print most of its own components. By making its designs freely available to the public, RepRap encouraged a do-it-yourself ethos among enthusiasts. This was a pivotal moment in the history of 3D printing, as it effectively transformed a high-tech industrial tool into a household item. The RepRap project also paved the way for the rise of consumer-oriented 3D printers. Companies like MakerBot capitalized on this trend, producing and selling affordable, easy-to-use 3D printers for the average consumer. MakerBot's Thing-O-Matic, for instance, was a hit among hobbyists and educators alike, further fueling the popularity of 3D printing. But it wasn't just about making plastic trinkets. These consumer-oriented 3D printers opened up a world of possibilities, from printing customized jewelry and home decor to creating educational models and even prosthetic limbs. 3D printing began to permeate various aspects of our lives. So the turn of the millennium wasn't just a game changer for 3D printing technology, it was a game changer for us, the people. It democratized the technology, making it accessible to anyone with a computer and an internet connection. Indeed, the 2000s democratized 3D printing, bringing this groundbreaking technology to our homes. 3D printing has come a long way, but where is it headed next? The future of 3D printing is as vast as our imaginations can take us. Let's dive into this captivating realm. One of the most riveting trends in the industry right now is metal 3D printing. With its ability to create complex, lightweight structures that are both robust and durable, it's no wonder that sectors like automotive and aerospace are turning to this technology. Imagine rockets that are lighter and more fuel efficient, or cars with intricate, efficient engines. That's the power of metal 3D printing. But that's not all. The field of bioprinting is also showing immense promise. Bioprinting, for those who are new to the term, involves the 3D printing of biological tissues and potentially whole organs. This could revolutionize healthcare, making organ transplants more accessible and less dependent on donor availability. Picture a world where a failing organ is not a death sentence, but a solvable problem. That's the potential of bioprinting. And let's not forget the advent of large-scale 3D printing. We're talking about 3D printing entire buildings or large parts of them. This could make construction faster, safer, and more environmentally friendly. Imagine a world where sustainable, affordable housing is available to everyone. That's the ambition of large-scale 3D printing, but of course, with all these advancements come challenges. Questions around regulation, intellectual property, and ethical considerations are all part of the equation. But these are not obstacles. Rather, they are opportunities for us to shape the future of this technology in a way that benefits society as a whole. Indeed, the future of 3D printing holds a plethora of exciting possibilities that could reshape our world. Whether it's creating more efficient machines, revolutionizing healthcare, or democratizing construction, 3D printing is at the forefront of these transformations. So let's buckle up, because the future of 3D printing promises to be a thrilling ride. The future of 3D printing holds exciting possibilities that could reshape our world. So what have we learned about the journey of 3D printing? We've traced the origins of 3D printing back to its humble beginnings in the 80s, an era where the concept of creating three-dimensional objects from a digital blueprint was nothing short of revolutionary. This groundbreaking invention, initially dubbed rapid prototyping, has certainly come a long way since its inception. We then navigated through the rapid development and expansion of 3D printing technology. From the creation of the first ever 3D printed part, a mere eyewash cup, to the current capability of printing complex structures like functioning organs and architectural marvels, the evolution has been nothing short of extraordinary. The pace at which this technology has expanded and evolved is a testament to human ingenuity and the relentless pursuit of innovation. We also explored the democratization of 3D printing and how it has become more accessible to the masses. No longer confined to the realms of high-end manufacturing and research labs, 3D printers are now found in schools, homes, and small businesses. The barriers to entry have been significantly lowered, paving the way for a new wave of innovators and creators. Looking ahead, we consider the future of 3D printing, a future that promises even more exciting possibilities. From printing human organs for transplantation to constructing habitats on Mars, the potential applications of 3D printing technology are as vast as our imagination. Throughout this journey, one thing has been abundantly clear: the transformative power of 3D printing technology. It has reshaped industries, sparked new ones, and has the potential to solve some of the world's most pressing challenges. 3D printing, a simple idea that started in the 80s, has indeed revolutionized the world, and its journey is far from over.